didn't go, did I? Your stuff moving. Okay. So today we are doing rational functions. We're graphing rational functions. And rational has the word ratio in it. What's ratio mean? It means we're comparing two numbers by division. It means we have fractions. So rational functions what we have is we have a different equation on the top, so maybe n of x divided by a different equation on the bottom, d of x. Can you guess why I called it n and d of x? Numerator and denominator! Good, you're so smart. All right, that way if I'm talking about n of x, you know I'm talking about the numerator. There's like, if you look at that first page, there's a lot of symbols on that first page. Okay, so what we're going to have is, we're going to have graphs that look like, kind of like graphs that we did at the very beginning of the year, where we had asymptotes. And then we had different branches that approach those asymptotes. Remember, we did that like a long time ago? We're coming back to it. It was actually in chapter 1, and now we're in chapter 2. So that's why we're doing it again, but we just do it at the end of the year instead. So we're going to be doing these kinds of things. So there's where the tedious stuff comes in. You got to figure out your asymptotes. When you look at the examples, we're going to be figuring out the domain. There might be graphs that have a hole in them. Oh, got that. There might be graphs that have a hole in them. Okay, so just get a little bit more complicated than that. Let's start. There's like a lot of notes at first, and I'm going to kind of skim over things and highlight things that are important and then give some examples. And then the actual examples are what are going to really help you, but you have the notes to go back to if you need them. So you see n of x and d of x. You see that all over here. One thing you notice is that there's no common factors. So our first step is going to be always to factor to make sure there are no common factors. That's always going to be our first step, is factor the n of x, the numerator, and the d of x. So our first step is going to be factoring our numerator and our denominator, check to see if there's any common factors. Then we're going to be answering a bunch of different questions. So one thing that we're going to be talking about are asymptotes. The graph of f has vertical asymptotes at the zeros of d of x. What does a zero mean? It could mean like an x-intercept. It's what x equals when the equation is equal to 0. So if we have an example like, you guys have more space to write like an example off to the side, either side. I don't have a lot of space up here, but if we have an example like f of x equals x squared over x plus 5. So there is a vertical asymptote at the 0 of the denominator. That means you take x plus 5 and you set it equal to 0, and what would x equal there? -5. That's our vertical asymptote. Vertical lines are always x equals. So that might help us know that we're looking at the denominator. Why can x not equal 5? -5. I mean, why can x not equal -5? Why is there like a skip in the graph? That's what I'm asking you. Because -5 plus 5 would make the denominator 0, and you can't do that. So the graph doesn't exist there. All right, the next, number 2, you'll see there's an A, B, and a C, and then there's something at the bottom that also goes to number 2. So there's an A, B, and C. These are horizontal asymptotes. These are horizontal asymptotes. You have to compare the degree of the numerator to the denominator. So remember we were going over a little bit degree. If the degree, now this gets confusing here. Let's just do this. If the degree of the numerator is less than the denominator, if the degree is less on top, the horizontal asymptote will be y equals 0. So if the degree on top is less than the degree on the bottom, y equals 0. That is the horizontal asymptote. That is, memorize that. Okay? If the degree of the numerator is equal to the degree of the denominator, I just changed it to D. You can change it to D up here. You know. If they're equal, what you have to do is you have to take the leading coefficients of the I don't like all these different things. We have to take the leading coefficients n over d, put it with y equals just that starting number. That's how you get the horizontal asymptote if they're equal degrees. See all these a's and b's and m's and n's, that's too much. So just like call them what they are, numerator, denominator. Okay. Let's pick up some examples for these two, and then we'll go on to C. So an example of A, f of x. Somebody give me a function that could be our top. Okay, let's make it where it is not factorable, where things would cancel, because that's something else. Okay. X squared over parenthesis x plus 1 to the third. There you go. So on the top we have a degree of 2. On the bottom, once you multiply all that out, we have a degree of 3. That would be the case where we have y equals 0. So how about let's make one up for B, and somebody else, because Avery did that one. So I want, just give me just a numerator. Give me an example of a numerator function. Who can give me a numerator function? Any function. X is better. Very creative. Now somebody give me a different function that we can't factor and cancel stuff. Okay, so something more creative, has more terms. Doesn't have many more terms, but somebody give me a different function, but it has to have a degree of 3.
X plus 4.
Ready? What?
X plus 4.
Let's not do it with parentheses. Let's have like the multiplied out one. You don't have to multiply out yours. Just give me one. We're done. We're ready. We're done. We're ready. Touch. Give me one. Give me a degree of 3. That's not perfect. Okay, so now we have a degree of 3 on top. We have a degree of 3 on the bottom. These are not going to factor and cancel. Okay, I just want to make sure we're doing that. So we have the same degree on top and bottom. So how do we find our asymptote, our horizontal asymptote? It's going to be y equals, and you guys have more space than I do. It's going to be y equals, and then we put the coefficient on top over the coefficient on the bottom, the leading coefficient. So what do I put? What over what? Coefficient, not coefficient, the number in front. So you just take 1 over 2, and that's it. So we have a horizontal asymptote at y equals half. That's it. All right, the third scenario. If the numerator is greater than the degree of the denominator, the graph has no horizontal asymptote. Let's do an example of that one. So somebody make up a numerator for me. Take some numerator, give me a function. Just make them up. Does that? And I need a more creative denominator. Well, and it has to have a degree less than 2. Perfect. So this has a degree higher on the top than on the bottom. This would have no horizontal asymptote. Okay. So there's 3 scenarios. But C kind of goes with our next section. Slant. If we have that same scenario of C, where it's more degree on top than bottom, and it's exactly one more degree on the top than the bottom, if it's exactly one more, then we have something called a slant asymptote, or you might see it called oblique. It just means like to the diagonal, this way or that way. We're going to have a line asymptote, but it's not going to be straight up or down. It's not going to be horizontal. Okay, so to find that equation of that asymptote, you actually have to divide these. So I see on top x squared minus 1, I'm going to divide that by x plus 1. And when I do division, I need to make sure I have zeros in. So if I'm actually missing the constant, I'll put the 0 in there. We're going to literally divide these. What? This is to find the slant asymptote, because the slant asymptote is going to be the equation of a line. Okay, so we have to find that line. This is how you do it. You divide them. So I take x into x squared, and it's a good thing we've been practicing this. And then you subtract, and you bring it on down, divide, multiply, subtract, and we are done dividing. Okay.
Why could you use like the
You could. I just didn't. You could. You can't always,
Right.
but you could always use long division.
Yeah.
So, but if you notice, you can use synthetic division because it's like just x plus 1 to do it. Just remember that 0. All right, now here's a great thing. We don't need the remainder. Somebody want to poke Dominic? Remind him I have to write a recommendation letter for him today. Okay. Today I'm doing it. Just saying. You can stand if you're tired, man. What? Oh, last night. Sorry. Okay. So what I just said was, when you're finding this equation, you can throw out the remainder. You don't need it. All you need is this up here. Y equals x minus 2 is the slant asymptote. So you just divide them, and then just the linear part of it, you don't use the remainder, just the linear part is your slant asymptote.
So if you ask us that, that'd be the answer. We don't do anything with the right part.
I don't really know.
Like that's it. Like that's all we have to do. Like you want to put that. That's the answer.
Y equals x minus 2 would be the slant asymptote. I'm not only asking you that, we're going to graph you. So you will apply it to something, but yeah, that's what you put on your slant asymptote line. Okay? Yes.
Why wasn't the speed like no horizontal asymptote? Because isn't that just when the numerator is greater than
There is no horizontal asymptote.
okay.
So slant is not horizontal, right? So if you have a slant, you won't have a horizontal.
So if the numerator is greater than the denominator, what's the numerator?
If the numerator is 1 greater than the denominator, you find a slant. If it's like 2 greater than the denominator, there wouldn't even be a slant. We won't have those. Okay. So we're only going to have like where there's 1, so you can practice this. We're not going to spend days on these. Okay. The next paper that you have, you've got a couple papers that just tell you exactly what I'm going to go through. Like if you forget how to find the y-intercept, it's in there. If you forget how to find the x-intercept, it's in there. It's all written in there, so you can go back and look through it. We're just going to do an example. All right. So example 1. Our very first step is we have to see if they have any common factors, because we can't answer all these questions if there's common factors. So our first step is to factor the numerator and the denominator. Factor the numerator, factor the denominator. Okay, so we're done with that one. Not factorable. All right, the next step you can look, we're going to be finding the domain. So I suggest the next thing you do after you factor it is set each factor in the denominator equal to 0 and solve. I haven't done that yet, but this is how we're going to get it. You're going to set the bottom equal to 0 and solve it. So in the bottom, what can x not equal? In the denominator, if x is 1, what happens? Then the denominator is 0. We can't divide by 0. X cannot equal 1 for this graph to happen. X cannot equal 1. So when we talk about the domain is what x's we're allowed to use. What x's are we allowed to use for this equation? Everything except for 1. We're going to go back in time, a long time ago when we did it in integral notation and redo that. So we're talking about all the x's except for 1. We're going to start at negative infinity, go all the way to 1. Then we're going to skip over it. So we'll put a parenthesis, we'll put a union, and then we'll start at 1 again, and we'll go to positive infinity. So that's telling us everything except for 1. I haven't talked to you about holes yet. I showed you a hole, but I haven't talked to you how to get them. The holes come from if you are able to factor and cancel factors, that's going to give you a hole. So we will have an example. We haven't had that yet. So for this, there's no holes. So it has to do with factoring and canceling. If you're writing notes, it has to do with factor and cancel some of your factors, but we haven't done that yet.
What is the thing where you put the squares instead of the parentheses next to the end?
That's if it equals the number, but it doesn't equal 1. And it's not going to equal for these, but that would be if it goes up to that number, equals it. Vertical asymptote. All right. So to find the vertical asymptotes, we look at what the denominator it can't equal 0. We look at what the denominator would be to make it equal 0, which I've already done. So our vertical asymptote is at x equals what number? 1. Vertical asymptotes always x equals some number. That's how we get a vertical line. So at x equals 1, I'm going to put an asymptote. Graphs are divided into like different pieces with vertical asymptotes. So I'm going to have 2 separate branches for this graph. Because we only have 1 asymptote, I have 2 separate branches divided by this. And what do I know about those asymptotes in that graph? What is not going to cross it. So there's like a wall that the 2 separate pieces can't get across. Next, horizontal asymptotes. So the horizontal asymptotes have to do with the degree. So if you don't have that memorized yet, then you've got to use those A, B, C. We need to know the degree of the numerator and the degree of the denominator. So what's the degree on top? What's the degree on the bottom? So they're the same. If they are the same, we put the leading coefficient of the top and the bottom. So we put 2 over 1. Y equals 2 over 1. So y equals 2. And it is the equation of a line, so I have to have y equals. That's a horizontal line. There's my asymptote. If we have a horizontal asymptote, will we have a slant? No. X-intercepts. So x-intercepts, how do we find x-intercepts like always? Plug 0 in for y, or f of x. So if I have f of x, or 0, equals 2x plus 1 over x minus 1. And I'm going to solve that equation. What I would do, since this is a fraction, I put this side over 1 and I'd cross multiply. If I cross multiply this, something great happens. What's 0 times anything? Okay, so I really just have 0 equals 2x plus 1. I'm really just solving 2x plus 1. So x equals what number? Negative half. I do not write on my blank x equals negative half. What is the question asking for?
Intercept.
An intercept. That means what? It's an ordered pair. So I write -1/2, 0. What happens if I don't write, Joey, this is questions for you. What happens if I don't write my ordered pairs in parentheses? If I don't write parentheses or my ordered pairs, what happens? Yeah, you're right, it doesn't mean anything. So like, if somebody's writing your quiz, just don't take off if you don't have parentheses and ordered pairs. Before you graduate, stop doing that. Alright. There's like 3 people. Somebody in my first period. What? I woke up with a migraine, and then I have somebody in XH that just loves to tell me how. There's some people that just really don't like you. I'm like, okay, thanks. Okay. I mean, like, how do you feel? All right, I'm gonna grab that. Well, see, I'm tough. I'm like, you know what? Not everybody likes everybody in the world. It's okay. And my job isn't to be a friend either. But it's true. It's true. It's true.
Her mom who's
Or didn't be.
I'm doing a dating for my mom.
But her mom had my mom. But she told me you, so I thought it was you. But you guys go to the church my mom goes to. That's the church I got married in. Good story. I forgot about that last one. Oh, and I'm glad I got that on the video too. All right. Y-intercept. Y-intercept. What will be fun is if that person watches the video and then
Wait, we talked
no.
the video is over.
No.
I think that's minutes.
Okay. Now we're going to find the y-intercept. How do we find the y-intercept though? Plug in. Plug in 0 for x. So we'll do 2 times 0 plus 1 over 0 minus 1. So I get 1 over -1, which is -1. 0, -1, y-intercept. Oh, I forgot to tell you, when you do this in calculus, like, I was, of course, conferencing with calculus teachers, and they say, this stuff, they do all kinds of crazy stuff with this, and it happens with, like, first derivatives and second derivatives, and they have to graph all these things, and it's all non-calculator. So we are doing this non-calculator, just so you know. We just don't have to do the first and second derivatives. You just have to do just. I know you don't learn this calculus. There's some calculus up right now. Those are integrals, not derivatives. But anyway. So when you look at this graph, I feel like I need some more points to know what the graph looks like. So I gave you a table, and I gave you the same table for every single one. So you don't have to fill up the table. It's there for you if you want to use it as organizing your work. So what we're going to do is you're going to pick some points that you have to make sure are on either side of this vertical asymptote. Either side. You have to have points on either side. This divides it into 2 halves. So I do have some on the left side, but I'm not quite sure as a brand new learner what the graph looks like. So I feel like I maybe want to pick at least one more point. And then we also think about what asymptotes are used for, because that will help us too. So let's pick an order, an x to plug in. That is to the left of -1/2. -2? Okay. Let's plug in -2. So we'll have 2 times -2 plus 1 over -2 minus 1. So I get -3 over -3. Come on. 2, 1? Did I do that right? -2, 1? Is that correct? Does it kind of look like the graph is going to branch through that? Does that look like it's not in a weird random spot? So hopefully you can start seeing, oh, I think the graph is going to get closer to this asymptote, never pass through it. And then it's also getting closer to this asymptote. Now, if you weren't sure, pick more numbers and plug them in. You should actually never, ever turn a graph in blank, because you can always just pick x's, plug them in, and get y's and start plotting. And people turn graphs in blank on that grid that we took last week. I mean, just like minimum work here, just plug this in. All right, that's not enough information. What else could I plug in? Something to the other side. 3? Okay. Let's plug in 3. 2 times 3 plus 1 over 3 minus 1. I get 7/2. 3.5. I can grab that. How about something else? 5? Oh, we could do 4 too. 2 times 5 plus 1. Oh, I think 4 works better. Over 5 minus 1, so I get 11/4. 2 3/4. Okay, what was 4? 4 would be 8 plus 1 over 3 would be 9, and the 3. Okay. 4 3 5 2 3/4. 4 3 5 2 3/4. You can see it's approaching the asymptote. You could have plugged in 2 as well. Did anybody plug in 2? What'd you get? Is it 2 5?
Yeah.
Okay. And then it's approaching that asymptote. All right, we did our first rational graph. Yay! Do I cross through the x, the up and down vertical asymptote? No. Don't do that. Questions before we go on? All right, let's go on. We will not go on past this one, and we might even finish this one before lunch. We'll see. What's the first step? Okay, let's factor the numerator and the denominator. That's the first step. Do any factors cancel? No. If none of them cancel, there's not going to be any holes. Okay. I'm just going to fill that out. Next, x does not equal what number here? 2 over here, x does not equal -2. So for our domain, we're going to go left to right, -infinity, and we're going to skip over, what's the first number when we go left to right that I'm skipping over? -2 first. So union that with -2 going to +2, union that with 2 going to +infinity. So we're skipping over -2 and +2 in order. Vertical asymptotes come from the denominator. So we look at our denominator, where are my vertical asymptotes? At x equals -2 and at x equals +2. So my graph is divided into 3 separate sections. 3 sections. We're going to have 3 different graphs going on. They're like the piecewise that we had done earlier in the year. 3 separate graphs happening. Now, horizontal asymptotes. That is where we have to look at the degree. So the degree of the top, 2. The degree of the bottom, 2. So how do we do it when the degrees are equal? Yes. So we'll do y equals 1. So are there slant asymptotes if there's a horizontal? No. X-intercepts. That's when we say f of x equals 0. Do you take I would take the factored one, x minus 3 over x plus 1. And it doesn't matter what's in the denominator, because just like the first example, whatever was in the denominator, I'll write it, but it doesn't matter. If I cross multiply to solve, the denominator will go away. It'll multiply with a 0. So we're really just solving the numerator equals 0. So what does x equal? 3 or -1. But we're not writing that as a list of numbers. We're writing it as ordered pairs. So we will have -1, 0, and 3, 0. And we'll go graph it as well. Y-intercept. Plug in 0 for y. When you go to plug in 0, it does not matter if you use the original equation or the factored equation. For me, I think it's easier to plug in 0 for this one rather than that one. But it's totally up to you. So I'm going to plug it into the original. So I'll have 0 squared minus 2 times 0 minus 3 over 0 squared minus 4. So I have -3 over -4, which is 3/4. 0 3/4. So now we need to find some extra points. Quite a few extra points. So how many sections is this graph sectioned into? Three equal sections. So I need to find some x's to the left of -2. Pick some numbers. -4, -3. Sure, try those. You do them. When you got to plug them in, it doesn't matter if you plug them into the original or the factored. I like to plug them in the factored one. I don't know why, but I do. I just can't see them both at the same time. Actually, I can because I know it's somewhere. Oh, I didn't even use that one. So I got 1 3/4. It's okay to get fractions. -4, 1 3/4. So -3, plug that one in. I get 2 2/5. Can you kind of tell what's happening? Yes or no? Okay, how about, first of all, what does the big red asymptote do to the graph? What's the graph do to the asymptote? It's going to get closer and closer and closer to it. It's not going to pass it. So I know, as I'm going this direction, I know it's going to do this. That's what asymptotes are used for. So over on this side, maybe if we plugged in one more number, we'll feel a little bit better about it. Maybe, maybe. Did anybody plug in a big number, like -10 or something? Nobody did? Okay, let's do -10. I haven't tried that one yet. So negative, that'll be, oh no, that's a horrible number. Might have to use a calculator if I chose that one, huh? Oh. I haven't done anything. What's the times 8? Nice. It's got a horrible answer. So that will be like 90 plus 27, right? 90 plus 27? 117, negative? No, positive 117? A little bit over 1. How accurate can you graph it, right? Okay, all I need to know is that it's a little bit over 1 because that's telling me this is getting closer and closer to the asymptote. Okay. And if you pick such horrible numbers, just pick different numbers that are easier for you to graph.
For the vertical asymptote, we can go by the denominator.
Yeah. Okay, what should we pick in the center? 0, 30 graphs. What should you pick? 1. Let's pick 1. All right. I get 4/3. Then I go graph it. 1 4/3. What just happened? No, it crossed the horizontal asymptote. When we have more than 2 sections like this, it is possible that sometimes the horizontal asymptote is only used for some of the sections. It will never, ever, ever pass through the vertical asymptotes. But sometimes it'll pass through the horizontal asymptote. And there will be this point of inflection there. And we will continue after that. I'll just repeat that right after that.